In this podcast, we're going to go over the IUPAC rules for naming aldehydes. Aldehydes are a group of organic compounds that have a carbonyl in them. And what makes an aldehyde and not a ketone is that your carbonyl group is going to be bonded to at least one other hydrogen atom. So it's going to appear that your carbonyl is at the end of a carbon chain. So you're going to have, and it doesn't matter how long this is, but you're going to have a carbon chain that's attached to your carbonyl, and this will be at the very end of it because there's an H and it does not continue on. If this carbon chain were to continue on past the carbonyl, we would then classify it as a ketone instead. We can also write aldehydes with an R group, C, H, and O. And so it's assumed when you write it this way that your carbon is attached to an oxygen and your carbon is also attached to a hydrogen. So you're going to have to do some assuming there that you don't just have a carbon that's not fulfilling the octet rule, that in fact this is a carbonyl, a C double bonded to O in this space. I don't like it abbreviated there, but you may see it from time to time in your textbook. Aldehydes are known for their distinctive odors, which you're going to find out in lab this week. All right, let's go over the rules for IUPAC naming of aldehydes. We're going to start the same place we always start. We are going to select the longest continuous carbon chain that contains the carbonyl. We're going to use the parent alkane name. So this is based on the number of carbons. And we're going to change the parent alkane name to the ending AL. So we're going to remove the E and add an AL at the end for aldehyde. The carbonyl in aldehydes is always considered carbon number 1, and this is because it's on the very, very end. So it's always going to get that coveted carbon number 1 position. Because of this, it also does not need to be numbered. It's always on carbon number 1. Then we're going to follow all previous rules. So we're going to then figure out the positioning of all of our branches, make sure that they're numbered, and as we name, we put those branches into alphabetical order. All right, let's do some naming practice for aldehydes. So we're going to start by identifying the longest chain. In this first example, the longest chain is a single carbon long. So we would use the parent alkane name methane, remove the E, and add an AL. It's really important when you're talking about aldehydes that you really enunciate that AL. So you say methanal so that it's not confused with a one carbon alcohol such as methanol. So you have to really enunciate. All right, in our second example, we have carbon number 1, 2. We have a 2-carbon chain. So we would name the parent name ethane. But remember, we drop the E and we add an AL. So this becomes ethanal. All right, in our third example, up at the top, we are going to find the longest chain and then we're going to worry about those branches. So again, always give this guy carbon number 1. 2, if I go down, that's only going to be 3 carbons long. I could also go upwards and count that branch above. That makes it 4 carbons, or we can just make this easy and make it a 4-carbon aldehyde. So let's start with the parent chain name. It's 4 carbons, so the parent chain is going to be butane, which becomes butanal. And we do not have to number the position of that aldehyde, that carbonyl, because it's always on carbon number 1. But we do have 2 methyl groups. So we have a methyl group on carbon 2 and 3, and I'm not going to have enough room to write that, so I'm going to write it up here. 2,3 dimethyl butanal is the name of this one. All right, in our last example, here's what I'm talking about. I do not like that abbreviation, but be on the lookout for it. The carbon obviously doesn't have enough bonds, so we have to assume that that is a carbonyl, a C double bonded to O in that position. So now we have to decide when we find the longest chain, are we going to go right, which will be 1, 2, 3, 4, or are we going to go left, which will be 1, 2, 3, 4, 5. I'm going to go left, so our longest chain is 5, which means this would be pentane, but I drop the E and I change it to an AL ending, so it's pentanal. And I am going to give this a branch name of ethyl, and that is coming off of carbon 2. So this would be 2-ethyl pentanal.